Good afternoon, dear students. Let us start our class, which is continuation of our previous class on lines and angles. So, dear students, so today we will discuss on parallel lines and a transversal and different relationship in different angles. Now, before I proceed further, I just want to confirm from a couple of you is that you are able to hear my voice very clearly and able to view the screen properly, dear students?
Yes,
Yes, sir. Yes,
Okay,
sir.
great. Thank you very much for the confirmation. So now, recall that a line which intersects two or more lines at distinct points is called a transversal. What is that? If I show you an example, means by means of a diagram. So if you look into this particular diagram, what we see is that that line L, which marked as L. Okay, and let me show you. This line L, as you see, what happened is that intersect the line M and N. There are two more lines. One is M and another one is N. That line L intersect lines M and N at points P and Q respectively. So these are the points P and Q, correct? And therefore, the L is a transversal line for M and N. Why? Because we know, just I said, what is transversal, that a line which intersect two or more lines. Here in this case, we took two straight lines, M and N, okay? And intersect two or more lines at distinct points. So here are the distinct points P and Q. So we can say that line L, which is intersecting line M and N, are called transversal line. Okay. So line L is a transversal for the lines M and N. Now, if we observe that four angles are formed at each of the points P and Q, if you notice. Now, let us name these angles, in a chronological order from 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now we are going to discuss about what is these angles. They are different names. Okay. Now, if you look into the angles 1, so you see that there are 8 angles here, dear students. Now, if you see angle 1, 2, 7, and 8, they are called exterior angles. So let me write it down. So exterior angles is angle 1, 2, 7, and 8. These four are exterior angles. Okay. And then the other four, that is 3, 4, 5, and 6, are called interior angles. So then what are the interior angles? Three, 4, 5, and 6. Okay. So these are called the interior angles. Now, we can name the some pair of angles formed with when a transversal line intersect two lines. What are those? Many of you actually studied it in your previous classes also, but let me confirm one thing, is that there is something called corresponding angles. What are the angles or corresponding angles, dear students? Angle 1 and angle 5, they are corresponding angles. Angle 2, angle 6, they are corresponding angles. Angle 4 and angle 8, they are corresponding angles. And angle 3 and 7, they are also corresponding angles. So let me write it down here. So first we discussed about exterior angles, then we discussed about interior angles, then we are discussing about that, corresponding angles. So what are the pairs or corresponding angles? So now we are going to discuss with the pair of angles. Angle 1 and 5, that is 1. Then it is coming angle 2 and 6, angle 2 and 6. Then it is coming angle 4 and 8, angle 4 and angle 8. And the last pair what we see is that angle 3 and 7, angle 3 and angle 7. They are known as the corresponding angles. Now the next part is coming is that alternate interior angles. Which are the alternate interior angles, dear students? If you look into angle 4 and 6, they are the alternate interior angles. Similarly, angle 3 and 5 are also alternate interior angles. So let me write it down here. So I can write it here. Alternate interior angles, angle 4 and 6. And the second pair is that angle 3 and 5. Angle 3 and angle 5. The next one, what we are going to discuss, dear students, is called the alternate exterior angles. Okay, alternate exterior angles are that angles 1 and 7, one pair, first pair, and second pair is 2 and 8. So let me write it down. Alternate exterior angles. Alternate exterior angles. The first one is called 1 and 7, angle 1, angle 7. And the second pair is that angle 2 and angle 8. Then the final thing is coming is that is called the interior angles on the same side of the transversal. Okay, what are those pairs? If you see that 4 and 5, that is the one pair, that is the interior angles on the same side of the transversal. And similarly, angle 3 and 6 are also the interior angles on the same side of the transversal. So what is the next one we are discussing, dear students? That interior angles on the same side of the transversal.
Sir, can these angles also be called co-interior angles?
Exactly, exactly. Interior angles on the same side of the transversal are also referred as consecutive interior angles or allied angles or co-interior angles. Exactly correct you are. Exactly. So what are those? So these are angle 4 and 5, angle 4 and 5. And the next pair, what we see is that angle 3 and 6. Angle 3 and angle 6. As you correctly said, so let me write it down. okay, also known as consecutive interior angles. Consecutive interior angles or allied angles or co-interior angles. Co-interior angles. So now, what I suggest you, dear students, so have a quick look into all these different terminologies what we have discussed so far. Okay, now what is our target? You know, our target is to find out the relation between the angles in these pairs when the lines M and N are parallel. That means when the line M is parallel to N, and converse is also true, the line N is parallel to M. That is our purpose, that we want to find out the relation between the angles in these pairs. Okay, what are the pairs we just I defined when the line M is parallel to line N. That the you can find out, you can construct this thing. So let me show you this corresponding diagram, and followed by let's discuss. So let me go to the next page, and so you see here that line M is parallel to the line N, and L is the transversal. Okay. With respect to the previous diagram, what I discussed in the previous page, there, line M and N was not parallel, but here we made it parallel. Now, what we are going to discuss, so let's see one by one. Okay. The first point, what I'm going to say is that, that in fact, before I proceed further, you can draw two parallel lines. Okay, how you can draw two parallel lines? You can take a scale. Okay, what is available with you? You can take a scale, and each edge of the scale you draw two straight lines along that scale. Then you find two parallel lines, and then you construct a transversal line. And after that, you name those lines the way I named it, like 1, 2, 3, 4, 5, 6, 7, 8. That means what I'm saying is that suppose you have a scale that that 6-inch or 12-inch scale you have in your geometry box. So then in the both the edges you draw this line. As you see, one is M and the other one is N. Okay, and if you do this thing, and then you measure those angles, and first have a transversal line L, and then you name those angles 1, 2, 3, 4, 5, 6, 7, 8 the way I named it. And if you measure, then one thing you will notice that angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. Okay, so that you will find it out if you notice. Okay, and from that in observation, what we can say is that the first axiom, what I can going to say, is that if a transversal line, or if a transversal intersects two parallel lines, then each pair of corresponding angles are equal. Okay, so what I'm going to write, if a transversal, the first statement what I'm going to write is that if a transversal if a transversal intersects two parallel lines, intersects two two parallel lines, then each pair of corresponding angles, then each pair of corresponding angles is equal. Okay. Now, this axiom, whatever I just wrote, is also known as corresponding angles axiom. Okay. So this is also known as, corresponding angle axiom. So I hope it is well understood, dear students. So now, let us discuss the converse of that statement, what I just wrote. So what is the converse of the statement? Converse of the statement stands like this. If a transversal intersect two lines such that the pair of corresponding angles is equal, then the two lines are parallel. That is the converse statement what we can draw, what we can say from the statement what I just wrote. Now let us see that how this statement is going to be true or not. Let's experiment. Okay. So now, so how to experiment? So for that, let us draw in the following thing. The first one what we are going to draw is that let's draw a line, and so let me first explain this thing. So what you see in this diagram, dear students, is that in this diagram you see there is a line AD, okay, and the line AD, and mark there are 2 points B and C. As we see here, there are 2 points B and C. Okay, and after that, let's construct the angle ABQ and BCS equal to each other. Okay, construct that angle, that ABQ and BCS equal to each other. That's what the converse. Okay, that what is the converse statement? If a transversal intersect two lines such that the pair of corresponding angles, okay, that means in this case what it is ABQ and BCS, correct? And in this case AD is the transversal. And what we are doing, so next statement, next activity what we are going to do is that let us produce that QB and SC to the other side of AB. That means if we make to the other sides of the AB, and then we can, the diagram will be looks like something like this. So let me first show it to you and then let me explain. So what I'm saying is that, yeah, as you see here, dear students, what we have done here is that, so let us produce QB and SC on the other side of AD to form two lines PQ and RS, as you see in the diagram. Now you may observe that the two lines do not intersect each other. Okay, you can make common perpendicular to the two lines PQ and RS at different points and measure their length. You will find it is same. That means what? You draw perpendicular, means if you make a perpendicular to both the lines, okay, you measure their distance, you measure this distance, you measure this distance, you'll find these distances are actually exactly equal to each other. Correct, dear students? So from there, so from here we can conclude that obviously these two lines, that is PQ and RS, are parallel to each other. So therefore, the converse of the corresponding angle axiom is also true. So what is the converse of the corresponding angle axiom? So converse of the corresponding axial converse of the corresponding angle axiom is like this. If a transversal, so what we can write from here is that it is something like this. If a transversal intersects two lines, if a transversal intersect two lines such that a pair of corresponding angles is equal, such that a pair of corresponding angles is equal, then the two lines are parallel to each other. Then the two lines are parallel to each other. And this is known as the converse of the corresponding angles axiom. So this is known as the converse of the correct, dear students?
Yes, sir.
Okay, great. Now let us see that whether that we can use the corresponding angle axiom to find out the relation between the alternate interior angles when a transversal intersect two parallel lines. So let us see this thing, that how we can make use of the corresponding angle axiom to find out the relation between the alternate interior angles when a transversal intersect two parallel lines. Let's see it. Okay, for that I'm going to draw a diagram, and and followed by I'm going to explain. If you see, dear students, here in this adjoining diagram, the two straight lines AB and CD are parallel, and PS is transversal. So that PS transversal intersect the parallel lines AB and CD at 2 points Q and R respectively. So what are the 2 points? So here are the 2 points. One is the point Q and another is the point R. Correct, dear students? Now, can we say that angle BQR and angle QRC equal, and angle AQR and angle QRD equal? Okay. One thing we can say is that angle PQA, notice very carefully, and in fact I'll appreciate if you also draw this diagram in your notebook, and also write down whatever I'm writing and or whatever I'm instructing. You see that PQA is equal to QRC. Okay, because from the we get it from the corresponding angles theorem, correct or not? I repeat, PQA is equal to QRC. That is the corresponding angle axiom. So what I'm going to write here is that PQA angle PQA is equal to angle QRC. Correct or not? And then what we can say, dear students, is that PQA, uh, you know, uh, one thing we can say is that PQA is equal to BQR. PQA is equal to BQR. Can someone please tell me why it is so? Angle PQA is equal to angle BQR.
Vertically opposite angles.
Correct. So then what we see? We see is that angle BQR is equal to angle QRC. So first we say that angle PQA is equal to angle QRC. And then we get PQA, angle PQA is equal to angle BQR. Now, if we combine together, then what we are going to get? If we combine together, we can say is that BQR is equal to angle QRC. Okay. So from 1 and 2, so from 1 and 2, we see angle BQR is equal to angle QRC. In the similar manner, the way I proved it, in the similar manner, you can also show that angle AQR is equal to angle QRD. So similarly, what we can show is that angle AQR is equal to angle QRD. Okay, dear students. Now, when we see that angle BQR is equal to angle QRC and angle AQR is equal to angle QRD, we are going to, make a new theorem. And the theorem is that if a transversal intersect two parallel lines, then each pair of alternate interior angles is equal, isn't it? So what we are going to write is that, so the statement what we conclude from here is that so the statement what I'm going to make it here, let me write it down. So the statement what we can write here is that if a transversal, if a transversal intersects two parallel lines, intersects two parallel lines, then each pair of alternate interior angles, then each pair of alternate interior angles is equal. Correct, dear students? Now, if we use the converse of the corresponding angle axiom, we can show the two lines parallel if a pair of alternate interior angles is equal. Correct? So, Let's understand this statement, what I just said, by means of this diagram. Okay, dear students, so let me first show you the diagram and then followed by let me explain. So if you see the diagram what I just placed, and what we see is that using the converse of the corresponding angles axiom, can we show that the two lines are parallel if a pair of alternate interior angles is equal? In the diagram, the transversal PS intersect the line AB and CD at points Q and R respectively, such that BQR is equal to QRC. Correct? Now, from here, can we say that AB is parallel to CD? Hopefully, let's derive it. Okay. So, in this one, what we see is that BQR is equal to QRC, right? So, angle BQR is equal to angle QRC. That is already given. And one conclusion we can draw, dear students, is that angle BQR is equal to angle PQA. Angle BQR is equal to angle PQA. Can someone please tell based on what we can conclude this thing? Angle BQR is equal to angle PQA.
So alternate interior angles.
BQR is equal to PQA. Are you sure?
Vertically opposite.
Exactly.
Yeah, vertically opposite.
That is a vertically opposite angle. Now, if we combine this together, suppose BQR is equal to QRC if we give as equation 1, and BQR is equal to PQA as equation 2. Now, if we combine these two, what we can conclude? We can conclude is that PQA is equal to QRC, correct? So, from 1 and 2, from 1 and 2, we conclude angle PQA is equal to angle QRC. So PQA is equal to angle QRC, but what they are? But they are corresponding angles, right, dear students? But they are corresponding angles, so definitely we can say AB is parallel to CD. So what you
Yes.
can, correct? But they are corresponding angles. So what you can say? So definitely we can conclude that AB is parallel to CD. So that we can conclude from the converse of the corresponding angles axiom. So now, based on whatever I have derived, so we can state this derivation by means of a theorem. And what is that, dear students? It is that if a transversal intersect two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Correct or not? So let me write it down. So we can conclude here, dear students. So let me write it down that if a transversal intersects two lines, if a transversal intersect two lines such that a pair of alternate interior angles such that a pair of alternate interior angles such that a pair of alternate interior angles is equal, then the two lines are parallel. Then the two lines, let me write properly, then the two lines are parallel. In the similar manner, you can obtain the following two theorems I am going to write related to the interior angles on the same side of the transversal. Okay, what are those? Let me write it down so that you have a very clear idea. Okay, so
They'll add up to 180, right?
correct. So that means is that exactly if a transversal intersect two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. And the second one, what we can say is that if a transversal intersect two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Correct or not? So let me write it down so that you just need to follow this statement, before you start solving any problems, and things will be absolutely clear. Okay, and it will work as a note to you. So if a transversal intersects two parallel lines, I'm writing slowly. You can also write along with me. Intersect two parallel lines, then each pair of interior angles, then each pair of then each pair of interior angles on the same side of the transversal on the same side of transversal is supplementary. Correct, dear students? And also, we can conclude before writing. Let me state so that you can get a proper idea. If a transversal intersect two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. So if a transversal intersects two lines such that a pair of interior angles such that a pair of interior angles such that a pair of interior angles on the same side of the transversal on the same side of the transversal on the same side of the transversal is supplementary, then the two lines are parallel. Correct, dear students?
Yes, sir.
Okay. You can verify all these statements what I wrote. Okay. Through simple activities, just with scale and pencil and measuring the angles, you can verify all these things. Okay. So now the next point what I'm going to discuss, dear students, is that the lines parallel to the same line. So let us understand this by means of first let me draw a diagram, then let me explain. So let me go to the next page and explain. So look into this diagram, dear students, as you see in front of your screen. If you see that that line T, okay, transversal to the line L, M, and N. It is given that M is parallel to L and N is parallel to L. So therefore, what we can say is that, let me write it down, that T is transversal as you see here, dear students, and it is given that M is parallel to L. So that means line M is parallel to line L. The next one is that line N is parallel to line L. Okay. So therefore, what we can say, definitely as you see the angles I have marked 1, 2, and 3, definitely angle 1 is equal to angle 2 and angle 1 is equal to angle 3. And why you are able to say this thing? Because of the corresponding angle axiom. Corresponding angles axiom help us to conclude that angle 1, so this implies what? Angle 1 is equal to angle 2 and angle 1 is equal to angle 3. Correct, dear students? From the corresponding angles axiom. So if we combine these two, what we can say? We can say this implies angle 2 is equal to angle 3. Correct, dear students? But if you see that angle 2 and angle 3 are corresponding angles and they are equal. Okay? So what we can say? We can say that line M is parallel to line N. So that means what? From here what we can say is that line M is parallel to line N. Okay. So now that when you say that line M is equal to line N, that we conclude from the converse of the corresponding angles axiom, dear students. So with whatever the logical conclusion I have done in one by one, it helps us to state the following theorem, that lines that are parallel to the same line are parallel to each other. I repeat the statement before I write. Lines which are parallel to the same line, the lines which are parallel to the same line are parallel to each other. For example, what? Line line M is parallel to line L, and line N is parallel to line L. So that means both the lines M and N are parallel to L. Okay. From there, what we conclude? So this is given. Line M is parallel to L, and line N, that is also parallel to L. And from there, what we are concluding? We are concluding that line M is parallel to line N, which leads us to state the following statement, that lines which are parallel to same line. So let me write it down. So lines which are parallel to the same line, lines which are parallel to the lines which are parallel to the same line are parallel to each other. I hope it is clearly understandable. Correct, dear students?
Yes,
Now,
sir.
now what we are going to do? Okay, now we are going to solve some problem together. Okay. So now the problem what we are going to discuss, there we need to apply whatever we have learned so far. Okay. So we are going to solve some problem related to the parallel lines. Okay. So what I'll suggest you, dear students, is that you open your notebook and also do along with me. Okay. So consider this diagram. Okay. In this diagram, so this is, I can write this as question number 1. So in this diagram, as you see, that PQ is parallel to RS, right? That PQ is parallel to RS, and angle MXQ is given as 135 degree. Angle MXQ is equal to 135 degree. Angle MYR is equal to 40 degree. Angle MYR is equal to 40 degree. Now, what is the question? We need to find the value of MXY. That is, sorry, XMY. So, find the angle XMY. Sorry, whatever, if I made any mistake, XMY, that you need to find it out. So, how to find it out? To solve this one, If someone of you already find it out,
Sir, is it 85?
yes, correct you are. It is 85 degrees. I hope all of you are. Let me. All of you have got this thing, or I can explain this thing. Let me
Sir,
explain.
1 minute.
Take time. No hurry. Take slowly. Take your comfortable thing. So we need to make a small drawing. Okay. So as you see in this, diagram, whatever
Yes,
I
sir. Is it 85
correct.
degrees?
It is 85. So as you see in the second diagram, so we draw a line AB which is parallel to the line PQ through the point M. Okay. Now AB is parallel to PQ and PQ is parallel to RS. Correct or not? We see that AB is parallel to PQ and PQ is parallel to RS. Okay. Now as we see this thing, then from here what we are going to say? We are going to say AB is parallel to RS from here, isn't it? If you recall that we just you know uh, conclude that theorem na, that the lines which are parallel to the same line are parallel to each other. Here the lines PQ and RS parallel to AB. Hence, PQ and RS are parallel to PQ and RS. PQ and sorry, AB and RS are parallel to PQ. AB is parallel to PQ and RS is also parallel to PQ. So hence AB and RS, they are parallel to each other. That's why we conclude AB is parallel to RS, correct? Now, from here what we see, dear students, is that angle XQM, angle XQM plus angle XMB, XMB is equal to 180 degree, correct? So, but according to the question, it is given that XQM is equal to 135 degree. Sorry, it is given is that QXM is equal to 135 degree. So from here, what we can write is that XMB. So from here, what we can write is that 135 degree plus angle XMB is equal to 180 degree. So from here, XMB is equal to 180 minus 135, that is equal to 45 degree. Correct, dear students? So what we get is that XMB is equal to 45 degree. Now, what we can say is that after that, what we can say, angle BMY, also what we can write is that angle BMY is equal to angle MYR is equal to MYR. BMY is equal to angle MYR. And what is angle MYR? Before that, how we can say that angle BMY is equal to angle MYR? Because AB is parallel to RS, alternate angles. So what we can say is that angle BMY is equal to 40 degree. So angle BMY is equal to 40 degree. MYR is already given as 40 degree na. So that is what we can write is that is equal to 40 degree is given. So now if we just add these two, so what we can get is that, so therefore finally we can write is that angle xmy is equal to angle xmb plus angle bmy. So from here you can write angle xmy is equal to 45 plus 40 degree. That implies angle xmy is equal to 85 degree. Many of you already found it out, but I took time to explain each and every step. Okay. Okay. So now, dear students, what the next statement, next one, um, I will appreciate that if you can send me your solution. Okay, just I'm going to send you this question, and if you send me your solution, then it is good. Otherwise, I can prove it here also. Write down the statement. I'm going to read, and please write it down. If a transversal intersect two lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are parallel. If the
Sir,
statement,
can you just repeat it once more?
yeah, sure. Let me write it down, okay? So that you can get this completely. Let me write it down in the next one, next page. Okay. Here is that if a transversal intersects two lines intersects two lines such that the bisectors of a pair of corresponding angles are parallel, such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are parallel. Then prove that the two lines are parallel. If the statement clear to you, dear students?
Yes, sir.
So, let me prove it, dear students. You can follow this statement along with me. Let us draw this diagram first. Okay. And I am going to, prove based on this diagram. So if you see in the adjoining diagram, a transversal AD intersects two lines PQ and RS at points B and C respectively. So this is the point B and this is the point C. Now, that BE, okay, is the bisector of the angle ABQ. I repeat, BE is the bisector of the angle ABQ, and CG is the bisector of the angle BCS. And BE is parallel to CG, correct? So what you need to prove? We need to prove that PQ is parallel to RS. Now, this is whatever the statement I just said, dear students, from the problem statement what have been given. Now, it is given that B is the bisector of ABQ. So what is ABE? Angle ABE is half of angle ABQ, correct or not? So angle ABE is equal to half of the angle ABQ. Let's give this as equation number 1. Now, angle BCG in the similar manner, that CG is the bisector of BCS. So what we can write? We can write that angle BCG is equal to half of the angle BCS. So angle BCG is equal to half of the angle BCS. Correct, my dear students? So this we give an equation number 2. Now, we know that BE and CG are parallel to each other. Now let's look into this way, that BE is parallel to CG and AD is the transversal. So BE is parallel to CG and AD is the transversal. So what we can conclude? Definitely we can conclude from the corresponding angles axiom that angle ABE is equal to angle BCG. Correct or not? So this implies angle ABE is equal to angle BCG. I repeat, dear students, that we are able to conclude with the assistance of corresponding angles axiom. Now let's give this as equation number 3. Now from these 3 equations, okay, if we substitute the value from equation 1 of ABE, which is 1 by 2 of ABQ, and BCG, which is 1 by 2 of BCS, what we can write? We can write is that half of ABQ is equal to half of BCS. Correct, no? From this equation 3 only we can write it down. This implies AB means half of angle ABQ is equal to half of angle BCG is half of angle BCS. So from here what we can write is that ABQ is equal to angle BCS. Correct? Correct, dear students? Absolutely clear? Now, what is this from this? What we can conclude from this? But they are corresponding angles formed by the transversal AD with PQ and RS. So definitely PQ is parallel to RS, and that we conclude from the converse of the corresponding angles axiom. So from here what we can say? So from here we can say is that PQ is parallel to RS. Dear students, you got it? All of you got it? Anyone has a smallest doubt, please do let me know. Okay. The next question, what we are going to do is that that is the last question for today, and I'm going to place the question here. So Let me first give you the diagram. Okay, look into this diagram, dear students. And in this diagram, it is given that AB is parallel to CD and CD is parallel to EF. Let me write it down. AB is parallel to CD and CD is parallel to EF. Also, it is given that EA is perpendicular to AB. EA is perpendicular to AB. These are the three things has been given. Now, as you see that there are three angles XYZ as it is shown in the diagram. Now, if angle BEF is equal to 55 degree, if angle BEF is equal to 55 degree, we need to find X, Y, and Z. So this is the task at our hand. Okay. So how to proceed? So dear student,
Sir,
yeah,
sir, is Z 35 degree and Y and X 125 degrees?
wonderful. Absolutely clear. You answered so quickly. Appreciate. Now, one thing is pretty simple that angle Y and angle 55 degree, they are 180 degree, dear students. Why? Interior angles on the same side of the transversal ED. Correct now? I hope all of you agree to me that
Yes.
1 plus 55 degree is equal to 180 degree. All of you agree to me? This is the interior angles of the same side of the transversal ED. So they must add up to 180 degree. So from here, what you can find is that the value of y, we find it out easily as, 180 degree minus 55 degree, that is equal to 125 degree. So value of y, we found it out. Now, x is also equal to y. Why you know? Because AB is parallel to CD according to the question. If AB is parallel to CD and angle y we are aware of, then definitely angle x should be equal to the angle y from the corresponding angles axiom. Correct or not? So x is equal
Yes.
to y. So now as we found x is equal to 125 degree, sorry, y is equal to 125 degree, as we found y is equal to 125 degree, so we can conclude that x is also equal to 125 degree. Correct? Now it is coming to find the value of the angle z. Now let's look into the problem statement once more. AB is parallel to CD and CD is parallel to EF. Correct? So therefore, AB is parallel to EF. Remember that the lines which are parallel to the same line are parallel to each other. So it is given that AB is parallel to CD according to the statement only, problem statement. And EF is parallel to CD. From these two, what we can conclude, dear students, that AB is definitely parallel to EF. AB is parallel to EF. Correct? Now, if AB is parallel to EF, then angle EAB plus angle FEA, okay, that should constitute to 180 degree. Why? Because interior angles on the same side of the transversal A. Okay. So what we can write is that angle EAB. So from here what we can write is that angle EAB plus angle FEA is equal to 180 degree. Now, what is angle EAB? FEA is already given as FEA is nothing but Z plus 55 degree, and angle EAB, we know it is 90 degree because EA is parallel to AB. So obviously angle EAB is 90 degree. Angle FEA is nothing but angle summation of the angle FEB plus angle BEA, that is equal to 55 degree plus Z, that is equal to 180 degree. Correct, dear students? So now from here what you find after simplification, we'll find the value of Z is equal to 35 degree. So we are able to find the value of XYZ, you know. So with this, I would like to conclude the class for today. Now, dear students, what you need to do, you need to appear for the DPP. In the last class, I didn't say about appearing for the DPP because this part was left. Now, as we are concluding, so you start appearing DPPs from lines and angles as available in the online test platform at konarclasses.com. So with this, I would like to conclude the class now. If you have any specific question, you can let me know. Okay. Thank you, dear students.
Sir,
Thank
how
you, sir.
DPP should we do?
Yeah, DPP. You do one DPP per day. One DPP you can do today, one tomorrow, like that. Okay.
Okay, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.